Welcome to the GE-MDS video training series. In this video, I'll be discussing the importance of NAT in the Orbit MCR device. First, I'll begin with an introduction of NAT, explaining why we need it and show an example of its importance. Then I will show how the Orbit uses NAT and why it's necessary on the cellular interface in particular. During this time, I will show where the NAT settings are located in the firewall rules and how it ties to an Orbit interface. Finally, I will show a unique Orbit use case in which NAT can be applied to a non-cellular interface. NAT stands for Network Address Translation. Its function is to modify the network address located in an IP header that gets sent across a routing device. The specific address being modified in each packet is the source IP address, or where the packet originated from. This is also known as masquerading. Displayed below, the data packet gets sent to the router device with NAT enabled. That router changes the source address of that data packet to the public IP address of the router. The most common use case for NAT is when a host with a private IP address wants access to the public internet. A class A, B, or C private IP address is not routable on the public domain. As pictured here, when the host requests data from the public web server, the request fails. In order for the host to access the web server, it needs to have its traffic routed and its source IP address modified by a routing device. To do this, a routing device is needed. Its place in the system is located between the two networks, in this case, the private and public network. When a data packet enters this router from the private side, the NAT functionality will modify the packet's source IP address and replace it with the router's public IP address. This can be seen in step 2. Once the source address is changed to a public IP address, it is now routable on the public domain and can reach the web server. When the web server sees the packet, it replies back to the router's public IP address, as shown in step 3. This NAT functionality ultimately allows an entire private network to live off of one public IP address. This next diagram shows the Orbit as the routing device connected to the public cell network through either a 3G or 4G connection. Orbit will now be the router that NATs all IP packets over the cellular interface from the private IP host. By default on 3G and 4G units, NAT is already configured and applied to the cellular interface. If NAT is not configured on the cellular interface, the cell provider will drop the connection whenever it sees an IP packet with a source address equal to a class A, B, or C private IP address. Now let's take a look at the configuration of NAT inside the Orbit and how it is tied to the cellular interface. At the Orbit's web interface, log in as the administrator. The NAT settings are located in the Firewall service. On the left-hand side, click Services, and then click on Firewall. Scroll down and click on NAT. The NAT feature we're covering in this video is the source NAT. Shown here is the masquerade rule. This rule is how your source IP is modified. To view this rule using the CLI, click CLI and then enter configuration mode by typing configure. Issue the command show services firewall NAT and press enter. This shows the configuration for the source NAT rule. To apply this rule to your interface, navigate to Interfaces and then select the interface you wish to configure NAT. Scroll to the NAT section and verify the rule mask is being used for the source NAT. Verify this on the CLI by issuing the command displayed. It's very important to not modify the mask rule unless you are doing IPsec or one-to-one NAT. See these videos for more information. The final case covered in this NAT video will show how non-cellular interface can also be used as source NAT. Pictured here is a 900 MHz link using a private subnet in the 192.168 address range. The MCR 900 remote has its Ethernet 1 port out of the bridge and using a private subnet in the 10.10 address range. This Ethernet port has source NAT configured with the mask rule. It can be thought that this port represents the WAN interface in the unit, similar to how the cell interface acted as the WAN interface in the beginning of this video. When the MCR 900 access point requests data from the data server, the remote NATs the source address, giving the data center connectivity back to the access point. If NAT was not enabled on the remote, then the data center would try to reply using the destination address of 192.168.x.y. It would not know where to send this packet, so it would be sent out its default gateway. The MCR 900 access point would never get the requested data. That's all for how SourceNAT works in the Orbit MCR. For additional information, please visit our website at www.gemds.com.